Good afternoon, colleagues. Today is going to be the next lecture for our Python programming course. And today we're going to talk about exceptions. Maybe you remember last time we talked about exception handling. We discussed try except blocks and considered some example of using them. Maybe you remember I told you about either ask forgiveness than permission rule, which we usually follow in Python. And today I'm going to show you some maybe more complicated examples of using this construction. So, how we can use try except blocks in Python? For the first, it's very important thing that usually we don't use bare except. What I mean, we can write something like try, then 5 divided by 0, then except, then print something like error. Let's try it works. We tried this our last time, but in this case, usually we don't do this in such way because it's possible to have a lot of problems with such construction. What is the problem? What is the reason of these problems? Actually, in this case, we use bare except. So this except doesn't have any. It doesn't catch some particular exceptions, but it can handle any possible exceptions. In this case, we know it's going to be a zero division error. But in the case if we have maybe more statements in this block, in try block, I mean, in this case we cannot be sure that we really have zero division error. We also can have some other exceptions in this case, and in such construction we can't be sure that some particular exception was handled by our try except block. So we sometimes say that try except blocks can hide exceptions because we don't know exactly what particular exception was occurred. How to avoid this problem? Actually, it always is better to explicitly tell Python what exception we are going to handle. Maybe you remember we tried our last time just to use this expression to calculate this expression, and you remember that type of exception which is raised here is zero division error. So it always will be better to provide the type of exception in our try except block. In this case it works in the same way, but if in this case we had some other types of exceptions, our except statement wouldn't handle it, and as a result we really can see that we really have an exception, and maybe our program will be interrupted, and in this case it will be easier to us to understand that we really have a problem. Otherwise, maybe our except can just ignore error, but as a result our data will be inconsistent state, and as a result our program will work incorrectly. And actually it's a dangerous case because then we can write this data to database or something like that, and after such cases we will have incorrect data in our database and so on. So to avoid this problem, we always should provide the name of exception which we are going to catch here. Maybe let's consider some other examples. I'm going to show you all possible syntax constructions in our try except blocks, and then we will see how they work in some different cases. To do that, maybe it makes sense to create, maybe just use text editor and run the program, because in this case I'm going to use exit function. I'm going to show you how exception handling works in the cases when we have when our program just is interrupted. So to do that, I can do that in Jupyter Notebook. So I'm going to create a new program for that. So what we're going to do? Let's just use our try block. Sorry, maybe let's save it in this folder, and maybe it can be something like accept.py. So let's declare some variable, for example, b equals 1. Then here we can do something like a equals 5 divided by b. Then we can provide accept branch and say that we are going to catch zero division error in this case. Then let's just print zero division error to see that this branch works. Then another case, it's possible to write more than one except blocks for different types of exceptions. So here we can try to catch something like name error. What is name error? It's an exception which is generated when we try to work with some particular variable, but this variable is not defined. You remember that Python is dynamic language, so it's possible to define variables in any particular lines of our code. So it's possible that for one particular for example, iteration of our loop, we don't have variable, and the next iteration this variable will be declared, so we will have this variable. So as a result, in case when a variable is undefined, isn't considered as something critical for our program. Instead of that, it's just a name error exception which can be handled. So in this case, we can print our message, for example, name error, and then I'm going to call exit function. This is a built-in function, and this function usually is used to interrupt execution of our program, just to interrupt program. Actually, exit interrupts Python interpreter, and we go to system shell after that. Also, we can use accept blocks. We can also use else block, else keyword in Python, try accept blocks. And here in this else block, we can write something like some code which we are going to execute if we don't have any exceptions. So here I can write print, for example, a equals a, something like that. Actually, this line can be also written here in this line, and we will have the same behavior. But just to make our code a little bit more readable, maybe. Or maybe to make this try block shorter, because it's important to make it as short as possible. In the case if we have large try blocks, in this case it's very difficult to say where our particular exception was raised. So we can think about one particular line of code, but really exception can be raised in another line of code. So to avoid these problems, we can just provide else blocks and move all correct behavior, which can be executed after correct when try block code in try block is correct to this else block. Then also we can provide finally block, and finally is executed always. This finally block is created for the cases when we allocate some resources and then we need to free them. It can be, for example, files, database connections, maybe sockets, and so on. For all types of objects in this case, we can just release resources in this finally block. the code in finally block is going to be executed always if we enter to try, so we can be sure that finally will be executed. Here we can just print finally to see that this line of code is executed. By the way, modern Python also provides keyword with, and this keyword can be used for handling resources, for releasing resources after using, but and we are going to talk about this a little bit later. But also we have finally, and we can also use it for such cases. Sorry, please. So also what I want to do, I want to add additional print statement at the end and print something like the end. Why I want to do that? I just want to show you that our program continues execution. So if a program will be interrupted somewhere in this try block, we will not see this the end. Otherwise, the end will be printed. Something like that. So let's try to run this code. What I'm going to do, I'm going to open another command line in my system shell, and I want to move this window to the right to make both my windows, I mean code and shell visible. And then let's just run our Python 3, then accept.py, and we will see how it works in the case when we don't have any errors. Let's run and let's discuss this case. So b equals 1. Then we enter to try block and try to divide 5 by b. It's possible to do, there are no problems with that, so this block is executed correctly. And we can exit from try block, and then Python interpreter skips these two lines to accepts, because we didn't have any errors in this case, and go to else block, and we print the message which we have here, something like a equals 5.0, sorry. Then after that we are going to execute finally, because finally is executed always. We can see finally message on our output. And then the end is printed because execution it wasn't interrupted, so this line number 14 was executed and the end was printed. So this is the simplest case when we don't have any errors. Let's consider some other examples, what we can also do here. I can change this value b to 0, yes. Now b equals 0, let's try to run our program again. What we can see here, b equals 0, then we go into try block and try to divide 5 by 0. It's not possible, of course. In this case, 0 division error is going to be raised. We go to this line number 5, because this type of exception corresponds the exception which was raised. And we print 0 division error, so this message is printed here. What Python is going to be after that? Now we consider our error as handled error. Yes, so we fix this error and we can continue execution. We don't need to interrupt our program. So the next accept is going to be skipped. Actually, only one accept block can be executed in one try block. Yes, if we executed the first block, so we are going to execute the second block. Then else we also are going to skip, because error was raised. Then we go to finally, because finally is executed always, and we continue execution, because now our error is handled. We don't have any problems with continuous execution. We can see that the end is printed. That's okay. Let's consider the third case. What I'm going to do, let's just comment this line and try to run the code again. What we can see here, We enter to try block and try to divide 5 by b, but b is not declared in this scope. We just comment this line, so as a result b is not declared. So name error is going to be raised. Now we have name error. We try to find a corresponding except block. We try the first block, but here we have zero division error, so we skip it. Then we go to the next block. Here we have name error, and that's okay. So we can really say that we have name error exception, and this block is going to be executed also in this case. We print name error, and then we exit from our program. We interrupt our program in this line, and as a result, we aren't going to go to line number 14 and print the end. Program in this case is interrupted before that. But we also can see that finally is printed again. Even if exit is written before finally, if we enter to try block, finally always execute. Finally always is executed. Even in the case if we exit before. So finally guarantees that our resources will be released after try block in any possible cases. Okay, so we can see that finally is printed here. Let's consider another example. What I'm going to do, I'm going to fix my errors. Let's change this b to 1, so we don't have any errors here, but I'm going to raise another error here. And how I can do that? There is a way to raise errors, some particular exceptions for some particular cases. Just explicitly, with some specific statement of the language. We can use language with the name raise. Actually, it's a keyword, and this keyword tells interpreter to raise an exception. Here we can write the type of exception. Let's raise something like value error, for example. Value error. Maybe remember this error is raised in the cases when for example, we try to convert some value to some particular data type or something like that. So let's raise value error, and also I can provide some message here, my message. This statement is similar to throw statement in other languages. Maybe if you have some experience with Java or C++, you know about throw statement. In this case, raise works in the same way. Let's see how it works. Let's run our program again. And what we can see here, we enter to try block. Then we can divide 5 by b, with there are no problems with that. Then we execute the next line, line number 4, and in this line exception is raised. As a result, interpreter understands that we have some problems in try block and starts to look for corresponding except branch. It checks the first branch, the second branch, but we can see that there are no branches with value error. Exception, and as a result Python interpreter can't fix an error which we have, which is raised. What it should do with that? Exception isn't handled, so a program should be interrupted, and you can see that program is interrupted. In try block we can see the message about so something like trace back. Then we can see that the exception is raised in line number 4 by statement raise value error. Then also we can see type of exception and message which was used to initialize this value error. So program is interrupted, and also we can see the end here because program was interrupted before line number 15. But also we can see that finally is printed, and it means that finally block was executed even in this case when we have an exception. and handle an exception. Yes. So this is a fourth example of our try except blocks. So in this case, I can say that maybe almost of all possible uh, combinations of try except blocks we have discussed. Also, sometimes someone can ask the question, okay, is it possible to handle all possible exceptions? Maybe this question is a little bit incorrect, because what it means if we handle all possible exceptions, it means that we want to try to fix an error and continue execution. Usually we do that in the case if we want to handle an exception. Yes, but if we actually don't know the type of exception, if we try to handle all possible exceptions. In this case, we can't be sure that our data is in consistent state. We have some unknown exception. We don't know what actually is the problem in this case, so we can't be sure that data is in correct state. Yes. Data is consistent. So maybe it doesn't make sense in general to catch any possible exceptions. But sometimes it can make sense. For example, it can be something like web application. Yes, a web application is run on server, and when exception is raised, we can just return a user something like HTTP error number 500, but also it makes sense to store some additional information about an error to the log. So we, in this case, we really want to catch all possible exceptions, and as a result, when we catch them, we can just store data about this exception to a log. So sometimes it can be useful. So how to do that? How to catch all possible exceptions? To try that, to understand how to do that, we should tell a few words about Python exceptions hierarchy. Let me show you. We can just try to Google. There are a lot of examples of Python exception hierarchy. Maybe we will find some image which shows them. Python exceptions hierarchy. Let's go to images, and what we can see here, there are a lot of examples of Python exceptions tree. For example, here we can see it. We can go to this site and take a look maybe in a little bit larger picture. Let's find it. This is a Python exception hierarchy. What it means? Actually, in Python, any exception is raised as an instance of some particular exception class. What are classes? Maybe we are going to talk about classes later, and we are going to discuss what are classes later. But maybe you have some experience with other languages, with Java, for example, and you or C++, and I'm sure that you know what are classes. So Python also object-oriented language, so it supports classes. This exceptions hierarchy defines the relations between our classes, and actually we can see that all exceptions are inherited from base exception class. And also, if we are going to talk about except blocks, we should know that if we catch high-level exception, in this case, all possible low-level exceptions also are going to be handled by this except line. So, for example, if we handle arithmetic error in the same block, we can handle zero division error, floating point error, and overflow error. If, for example, we handle exception, then we can also handle attribute error, arithmetic error, and so on. All exceptions which are inherited from an exception. It means that if we try to catch base exception, in this case we will catch all possible exceptions. But usually instead of base exception we just catch exception. Why we do that in such a way? Because you can see that base exception also is a superclass for keyboard interrupt exception. What is keyboard interrupt exception? This exception is raised in the case when we press Ctrl C in our keyboard. It means that we want to interrupt our code. So if we catch, for example, base exception, in this case it's possible also to catch keyboard interrupt, and potentially it's possible to write program which will not be will be impossible to interrupt with Control C, and maybe it's not a very good idea to write such programs. So this is a reason why we don't use base exceptions in such cases. Instead of that, we just catch exception class. And how we usually do that? Let me show you an example. Let's try to write accept exception. Also, we can use as keyword and provide some variable name for variable which is going to be used for storing raised exception. So exception is going to be raised, then we catch this exception and store the instance of exception class in this variable e. What is interesting, maybe you know, in Python we don't have something like block scope. So it's not possible to define variables in block, any variable which we are going to define. Actually, it's possible to define variable in block, but it's going to be global variable. It will not be block scope as in, for example, C++ or Java. But for this variable e, it's something like exception. And this variable is going to be local for this block variable. Let's print e and see what exception was raised. Let's run our code. And what we can see here, we enter in try block, then we raise an exception, and then the first our except block actually handles this exception. When we just print e, it prints our message which we used when we created our exception. We also can extract all information about exception from this e object. We can find the line in which we have an exception. We can find all of these trace back, the type of exception, and so on. So if we want to do that, we can analyze this object and get all necessary information about exception which was occurred. So in this case, we really can catch all possible exceptions. But in this case, we also have another problem. Let me show you. If we change b to 0 and run our code, what we will see here? We can see that now our message is division by 0. And what is the reason of this message? Let's go to our notebook and see. Let's just take a look at this traceback from zero division error. We can see that actually this is a message, division by 0. So we can say that in this case again this line was executed, and it's a little bit incorrect because we have more specific except block here. So we have zero division error, but this except block, because this is a high level exception, it handles this exception, and as a result any other blocks aren't going to be executed. We can say that if we have exception at the beginning of our try except block, then any other except blocks actually cannot be achieved. How to avoid this problem? Maybe it makes sense to take this block and move it to the end of our except blocks. And actually there's a general rule we always try to catch more specific exceptions before more general exceptions. The very important rule. Actually, it works in the same way, for example, in Java language. So it's not, maybe we can say that it's maybe some strange behavior or something like that. It's a traditional behavior, and we should remember that always we should write except blocks for less general, more specific exceptions, and then for more general exceptions after that. Otherwise, all our excepts, these excepts will not work in any possible cases. So now, if we run our program, we can see that our zero division handler works correctly. So maybe that's all about try except blocks, all possible combinations of such blocks and so on. And maybe in general, maybe that's enough about exceptions in general, yes. There are some other, maybe a little bit less specific things which we can also know about exceptions, but maybe for now it doesn't make sense to discuss. Only one additional syntax construction. Maybe I can show you only one additional syntax construction. Sometimes it's possible to use a raise. Raise, you remember, raise is used to throw an error. We can use raise without exception type. If I try to do that just as in my code, you can see that it's going to be runtime error, no active exception to raise. So it's not possible to do in the top level of our code. But this raise statement actually is possible to use it in except block. Let me show you an example. Suppose we have a try block, then we want to divide something by 0, then we write except zero division error as usual. Then I want to maybe print something like error, and then I want to re-raise my exception. So I have some handler here, but I also want to report to my high-level code about my exception. How I can do that? I can re-raise my exception. I can raise zero division error again to say that we have the problem here. Let's see how this line works. Now in modern Python, usually we have something which we call exception chains. So we can see that we have zero division error. And during handling this exception, we have another exception. So this chain of exception tells us all steps, all exceptions which were raised in all our code. That's good, but what is the problem in this case? You can see that the last exception which was raised actually was in line number 5. But we really know that our exception was raised firstly in line number 2. Maybe this traceback, this report is not accurate enough, and maybe we want to make it a little bit better. To do that, I can just use raise without exception type. Let's see what we can see here. And this raise without exception type actually is used only just for re-raising an exception. So our exception is exception object is taken in this except block. Then we can do some particular things for to fix this error. Then we raise our error, re-raise our existing error again. We use the same instance of zero division class in this case. So this is a case when it's possible to use raise without exception type. So sometimes it can be useful in large programs if we want to tell our high-level code about problems. Then And also we want to have, fix an error inside of our block, or maybe do something with this error inside of block, and then report error. In this case, we can use arrays without exception type. Maybe that's all about exceptions. Later we will see some examples of using exceptions, but now maybe let's continue, and the next statement which we are going to discuss is going to be if statement. Oh, sorry, if while statement. Sorry, a loop statement for making loops. You know that any modern language, programming language, usually, maybe if any imperative language has some statements for branching and also for loops. Python also has statements for creation loops. Let's discuss them in this case. Maybe you know that usually we have in modern languages we have 4 different types of loops. Actually, it can be loop with precondition, loop with postcondition. It can be also a loop with a counter, and it can be range-based loop or for each loop. Loop with precondition has condition at the beginning of the loop. Loop with postcondition has condition at the end of the loop. Loop with the counter uses some particular counter, and usually this loop in this loop our interpreter or compiler automatically increments this counter, and it checks some conditions and so on. And for each loop, there's a specific loop which allows us to iterate over some collections, some containers, and so on. What about Python? In this case, we have only 2 types of loops. It's loop with precondition or while loop, and also for each loop. And actually, it's enough for Python. You know that Python has simple enough syntax, so really in almost all cases, maybe in all cases, it's enough to have only 2 types of loops. Let's start with loops with precondition. Let's see how we can write while loops and how we can use them. Let's define some variable. Then we can write while keyword. It is used for for the first line of loop. Then we can provide some conditions, something like I less than 5, for example. I'm going to make 5 iterations in this case. Let's print I. Oh, sorry. Let's print I. And then increment I. It's always important to make some modification for loop variables. Without that, we will have something like endless loop which cannot be interrupted, and it can be a problem. So in this case, you can see that this code executes the loop 5 times. I equals 0. Then we enter to the loop, check the condition. I less than 5, so we enter to the loop, print I, increment I, go to the beginning, check condition again, and so on. We do that exactly 5 times before finishing. By the way, it's comparably rare case when we use while loops. The reason is that in almost all cases we can just use for each loops, and they are more convenient, and we just need to write less code, and when we write less code we just do less errors. So it will be better to always use for each loops, but sometimes it's not possible because sometimes we just don't know how many iterations we want to do. Yes. And for the cases when the number of iterations is not known, in such cases we just can use while loops. Let's also discuss some examples of using while loops. For the first, let's see how to interrupt the loop. Maybe in the middle of the loop, something like that. Let's consider a function which allows us to input some data from keyboard. I don't remember, maybe we discussed it before, but let me just remind you. So there is a function input which can take some prompt, some message which can be printed to user, and then when we run this code, Python usually interrupts execution of our program and waits for user input. I can provide any string here, then press enter, and then our variable s, we can see that it contains user input, but always it contains a string. This result always has str type. So input doesn't try to convert this value to some other types, maybe it just returns str. So now we have a str value, and then for example I want to interact with user. I want to ask user, for example, I have some program I do something for my user, and then I want to ask him if he wants to interrupt execution or not. How to do that? Actually, I can write the code in such way. I can write while true. And maybe we have some useful way, we can do some useful things. Now it's not important what we're going to do here. Then we can ask user if we want to continue or not. Some confirmation equals input, continue. As usual, yes or no, yes. By the way, Python has something like functions which can be applied for our objects, and by the way, what is important in Python, anything is an object. So we can apply functions for some specific functions for any objects. We usually call these functions as methods. And what about str data type? It has a lot of built-in methods. In particular, we have method which we call upper. This method is used to convert all letters in our string to uppercase. So why we can do that? Just to allow user to enter uppercase and lowercase yes or no. So then we can check if our confirm variable equals no, we want to interrupt our loop, then we can use break statement. How it works? Let's try to run it and see what it does. So we enter to while block, then we do some useful things, then we ask user for continue or not. Maybe it will be better to add question mark here. Yes, let's try again. I'm sorry, we should interrupt it and then maybe run again. It asks for yes or no, so let's say yes. You can see that we go to the next iteration of the loop. So loop is going to be to run a lot of times while we will provide value n. Then in this case loop is interrupted. So this break statement interrupts our loop, and it can be useful for the cases if we want to do something like loops with post conditions. Maybe you can see in this case we have a loop with precondition, but now we create a loop with post condition. Also, let's consider some other examples. Suppose we want to ask user to enter integer value. Yes, we want to ask for some value, and if value is integer, we can just print it. If it is not integer, we can continue execution and ask for other number. Let's try to do that. Again, it's going to be while true. Then we can ask user for integer, and because I want to have integer value, I should convert this value to integer data type. You know that Python has explicit type conversions, so I can just use int as a function, type name as a function, and convert my data to integer. But also it's possible for a user to provide maybe some incorrect values. He can provide some values which cannot be converted to integers. We can't believe users because they can provide anything and can type anything. So as a result, maybe we should add also try block, then catch an error, accept block, accept value error. And what we are going to do, maybe it makes sense to print a user something like incorrect number, and later we want just to print a number which user inputs. But if it's the case, if user inputs something incorrect, we can't continue, we can't go to this line because we don't have correct number. What we can do with that? We can just use continue statement. What continue does? It goes to the next iteration of our loop. If condition, if value is okay, so it is integer, we just keep except block and print the result on our output. In the case if our value is not correct integer, then we go to except block and do continue, so we go to the next iteration of while loop. Let's try and check how it works. So it asks for integer, let's provide correct integer, you can see that it works. Now let's provide something incorrect, and it prints incorrect number and doesn't print anything as a number. Yes, let's just provide another number. You can see that it works, and so on. By the way, this code doesn't have any correct way to interrupt it, so let's just press Ctrl C and interrupt code in such way. So this is a second statement which can be used in our loops. We can use break statement, and also we can use continue statement. Like in other languages, maybe in C++, in Java, in C, and so on, in all modern languages we usually have break and continue statements for to control our loops, to go to the next iteration or to interrupt loop. There are no maybe some specific things in here. Also, I want to show you an example where we can have some really specific things with Python loops. Actually, the construction which can be used only in Python. I haven't seen such construction in any other languages, so I think that maybe this construction can be used only in Python. Suppose we have a string. Yes, we have a string, something like hello. And we are going to write the code which can go through the string and look for some particular character. For example, we want to find the position of character E. Yes, we have character E, and we want to find the position of this character. Let's just provide some counter. Then we can do something like while I less than the length of our string. Then we can check if current character si equals E, so we can say that value is found, so we can print I and then do break. we can interrupt execution of our loop. Also, we should increment the value. So as a result, we'll go to the next and the next, I and so on. Let's try. Our program works. Really, E is located on the first position. The first character has index 0, as you remember. The next has index 1. So our program works correctly. But then let's just try to do the same with some other character which is absent in our string. For example, I don't know, maybe Q. Yes, we don't have this. I'm sorry, don't have character Q in our string. Let's try. So now our program doesn't print anything because in this case our loop goes to the end of the string. When I equals to length of the string, we just exit from the loop and we do nothing. But maybe for this case we also want to print something like item isn't found or something like that. So we want to tell user that there are some problems with this item. How we can do that? Usually in other languages we provide another check, another if. Here we can check a condition that something like I don't know, I equals len of s, and maybe we can print I don't know, not found, just not found for that. And maybe it will work. It works, we can see, but maybe this approach isn't very good because we have a duplication of the code in this case, where we have this duplication. You can see that this condition is almost the same as this condition. If later we want to change this condition, then we also need to change this condition. And maybe this is not good practice to have duplication in the code. Maybe you know that usually one of the most the biggest problem in our code is actually duplication. So how we can avoid this problem here in this code? Python provides additional syntax for such cases. Instead of this condition, we can just write just a else after the loop. How else works? In the case if we exit from our loop by break, then Python will not execute this else block. In the case if we exit from our loop by this condition, I can say in natural way, yes. In this case, else is always executed. So in general, we can say that we can write else after any possible loops. But in the case if we don't have a break inside, in this case it just doesn't make sense. Because this code will be executed always. Yes, if we don't have break, this code will be executed always. But in the case if we have break, then this code will be executed only if we didn't exit from the loop by break. That's all. And actually it seems to be very convenient. By the way, it doesn't require something like break with label like in other languages when we have nested loops. You know, in some languages we can write something like break with some particular label to tell which particular loop should be interrupted. In Python we don't need that because we can also provide else and use break inside if we want to interrupt those loops. And so on. So this is such a specific syntax which as I said, I haven't seen in any other languages. It is provided only for Python. And it's really convenient, so please remember about that. Also, what I want to say, later we are going to talk about for each loops. We will see how to write for loops. And we will see that for each loops also can In for each loops, we also can use break, we can use continue, and we can use else after the loop. So all of these constructions we can use after we can use in both types of loops. Actually, maybe that's all about while loop. As I said, we don't use it very often. Usually we use it only in the cases when we don't know a number of iterations. And it can be used in some numeric methods when we want to continue execution while we don't have enough precision for our calculations. Or, for example, sometimes we use it to work with user input, or maybe we're working with databases or some other sources of data where we don't know how many iterations we are going to have, something like that. Then the next type of loop is for each, but for using for each loops, we use for each loops usually for working with containers. And for now we know only one container type. It's actually string type. Later we are going to discuss some other containers like lists, tuples, dictionaries, and so on. And after that, I think that we can consider for each loops and see how they work also. Maybe that's enough for today. Thank you, colleagues, for your attention, and goodbye.